Hey guys, welcome to this video of just examples of tricky definite integrals that are non-trig, so they do not feature trig. If you're looking specifically for trig, I have another video on that. So let's just jump right into it. So here are the 4 examples I'm going to cover in this video. So if you want to use this video as an opportunity just to quiz yourself, I highly recommend pausing and trying them, and then you can watch the solutions, or if there's one that you're specifically looking for, you can just jump to that. So let's just jump right into it. Okay, so I've got A here. So for this particular problem, so this is like kind of a common, this is a common thing that can come up. And so there's more than one way to actually solve this particular problem, but if you don't know anything else, and if you've just learned how to work with integrals, then usually the answer is you want to FOIL this out. So you're just going to have to kind of work out this whole part. So this is x squared plus 2x plus 1. And so once you do that, then you can just evaluate all of the pieces of it. So if I go ahead now and I go to the next step, this is 1/3 x cubed plus x squared plus x, and I need to now just evaluate this from these limits of integration. Okay, so now I just plug everything in. So I'm going to plug in the 5 as shown, and then I'm going to plug in the 3 as shown. Hopefully I don't run out of room. Sorry, my handwriting's getting a little hard to read. Let's see, plus 3 squared plus 3. So there's basically now what I just have to go through and work out. So this will come out to 125 over 3. This comes out to 25. This is still 5. This is going to be minus 9 plus 9 plus 3. And then if you work all of that out and you add it all together, you can round this to 50.67. Or you can put that in fractional form, whichever way you need it. So that's kind of the idea behind that particular one. Okay, moving on to the next one. So this is actually like maybe not the trickiest actually, but one thing that does throw people off, I'll just show you. So if I take the antiderivative here, so the antiderivative, so this is going to be, I'm going to break out the 1/3 and then I'll multiply this by 1 over 7 x to the 7th. So there's the antiderivative of this first part. The thing that I notice a lot when I have student tests, this one always just like kills people, 1 over x. So I don't really know if I have a great piece of advice for this other than you just have to remember this. And this is something I struggled with too, and I think it's really common for people to struggle with it. So just remember with 1 over x, this is the natural log of x. And a lot of times people put absolute value around this. A lot of times with definite integrals, though, you don't need that as long as you're plugging in things that are going to be positive. So I guess I'm kind of omitting that. Technically, people put, like I said, absolute value around this. So if you do or don't, it still works out to be okay in this case. So this is just the one, I think, for me at least, just the way that I learn. I just had to get this wrong enough times until I remembered. So it's just something that's got to kind of stick out in your mind. So this is just 1 over x is specifically natural log. Okay, so here's kind of everything. So now I've basically got to just plug in these other parts. So this will be 1 over 21 times 3 to the 7th minus the natural log of 3. So now I can definitely drop the absolute value. And now I can subtract off. So this will be 1 over 21 times 1 to the 7th is just 1. So I'll just leave this as 1 minus the natural log of 1. And so if I work all of this out, so then I ultimately will get, so I'll just tell you what the answer comes out to. So I get 102.9966, so that's what everything kind of rounds out to. So that's kind of it for that one. Okay, so this next one is like a pretty standard trick that you have to use. So in general, so it's not always true, but a lot of times when you're working with things like this, what you want to do is you want to break up the fraction into pieces, if that's possible. So in this case, this is possible. So if I break this particular fraction up into pieces, so here's kind of my pieces, and from here now what you want to do is you just want to simplify what you see here. So x divided by x is just 1, and then so when I take square root of x over x, this will simplify to 1 over the square root of x. However, personally, the way I prefer to state that is x to the negative 1/2. Just for some reason in my brain, when I'm trying to find the antiderivative, it's easier if I can just see the exponent, but you do you. Okay, so now I can go ahead and find my antiderivative. So the antiderivative of 1 is just x, and then the antiderivative of x to the negative 1/2, this will be 2x to the positive 1/2. And so now I can just plug in my limits of integration. So this will come out to 4 plus 2 times, we'll call this the square root of 4, minus 0 plus 2 times the square root of 0. And if you work all that good stuff out, you'll just get 8. So 8 is the answer in this case. Okay, and so now for this last one, so now I need to take the integral of the absolute value of x. So you can actually do this, technically you could do this just totally from a graphical standpoint. If you just drew this out, so maybe I'll just show you a quick sketch. So if I draw this out, so I get something that looks like this. And so basically I can go from -2 to 2. So basically what you could do from the sketch is you could just find the area of the two triangles. That is like one really good way to do this if you just are totally out of ideas. But the other thing to keep in mind with the graph here, so the thing that really matters is that we are kind of at the point. So here at 0, 0, this is where the graph kind of changes directions. So on this side, what is this side's graph? This side's graph is negative x, and then on this side's graph is x. So there's kind of like the two pieces. So if I want to actually integrate this, what I can do is I can break this up into two parts. So this is actually kind of flexing on some properties of definite integrals. So from -2 to 0, this part of the graph is negative x. So that's something that I can actually integrate. So I can do this. And then from 0 to 2, this leg is just x. So there are your two pieces. So you can actually break it up and then just go this way. And so then if I find my antiderivatives, so this will be -1/2 x squared, and now I need to evaluate that from -2 to 0. And then for this other one, this is x squared, and I need to evaluate that from 0 to 2. So now I can just kind of go through that. So this is, let's see, -1/2 times 0 squared minus -1/2 times -2 squared. So that's working on this first part here. And now plus, oops, and sorry, this was 1/2 here, my bad. This should be 1/2 x squared. So this will be plus 1/2 times 2 squared minus 1/2 times 0 squared. So there's kind of everything plugged in. So then this comes out to really, let's see, this comes out to 2 plus 2, so ultimately this will equal 4. And then if you want to back this up, you can, like I said, you can actually just kind of compute the area of these two triangles from the graph, and you will get the same answer. So that's actually a really nice way to kind of convince yourself of what the integral stands for. And so that covers it in this video. So those are all the tricky non-trig integrals that I have for you. So if you have any questions or anything like that, feel free to leave them in the comments. And if you're looking for more videos, I have lots of other videos on these topics. So hopefully I'll see you next time.